Hello, good day everyone, and I'm back again for another video. So hi, my name is Antoinette C. Pahanoy of ECE 3A, and I'm going to discuss to you a certain topic from my performance task number 8 with this learning objective. So to demonstrate the principles of information theory by determining the entropy in sending a message and by using Shannon's and Hartley equation. And based only on the resulting letters of my name, which is ACEHJNOPTY, we need to determine the two different binary machines and find the probability of the occurrence of each letter based on the binary machine. And then I'm going to compute for entropy using probability method and then using Hartley equation or Hartley function. And the last one, we need to make a summary by comparing the result and draw a conclusion on which machine is better. All right, let's start with binary machine number 1. So this is the probabilities. These are, and these are the number of bits. So let's start with the this combination of my name or the combined letters of my name, ACEHJNOPTY. So starting with letter A, there's A here, and that is 1. Number of bits is 1. So how do we get a probability? That is 2 raised to negative 9 n. So for example, the number of the n is 1. So 2 raised to negative 1 is 0.5. And then follow on the other probabilities here of the letter. And then start with C. So C has 0, 1, 1, 1, and 1. So that they're total of 5. So 2 raised to negative 5, that will be 0.03125. For the E, we have here 0, 1, 1, and then 1, and then 0. So that will be a total of 5. Still 0.03125. And for the H, we have here 0, and then 1, and then 1, and then 0, and then 1. So that's still a total of 5. So the probability is 0.3125. For the J, that will be 0, 1, 1, and then 0 and 0. So that will be still total of 5 number of bits. So still probability of 0.03125. And for the N, that will be 0, and then 1, and then 0. So that will be total of 3. So 2 raised to negative 3, that will be 0.125. For the 0, for the letter O, that will be 0, 0, and then 1, 1, and then 1. So total number is 5. So that will be 0.3125. For the letter P, we do have 0, 0, and then 1, 1, and then 0. It's still number of 5. So the probability is 0.03125. Letter T, we have 0, 0, and then 1, and then 0. So there are total of 4 number of bits. So 2 raised to negative 4 is 0.0625. And the last one is letter Y. So that is 0, 0, 0. So a total number of bits is 3. So that will be is equal to 0.125. So these two equations here. First is using the probability method, and where this is the solution. 1 times 0.5 times 1 plus 2 times 0.125 times 3, and then 1 times 0.0625 times 4 bits, 6 times 0.103.0.03125 times 5 is a total of 2.437 bits for this equation. And the same with this second equation here, because this is using a Hartley equation or Hartley function. So the solution is negative times 1 times 0.125 log of 0.5 base 2, and then plus 2 times 0.125 log of 0.125 to the base 2, and plus 1 times 0.0625 log of 0.0625 to the base 2, and then 6 added to 6 times 0.03125 log of 0.03125 to the base 2. So the equation is equal to 2.4375 bits. So that is still the same. So this is the entropy for this binary machine number 1. So I have here a binary machine number 2. So this is the totally different structure and arrangements of letters. So starting with letter A, so we have here 1, 1, 1, a total number of 3, so the probability is 0.125. For letter C, we have 1, 1, 0, 1, so that is total of 4, so the probability is 0.0625. And then for the letter E, we have here 1, 1, and then 0, 0, of total of 4, still 0.0625. Letter H is equal to 1, and then 0, and then 1, 1, 1, a total number of 5, so the probability is 0.03125. For the letter J, we have 1, 0, 1, 1, 0, a still total of number 5, so still 0.03125. Letter N, we have 1, and then 0, 1, 1, 0, and then 1. So a total of 0.03125. So the letter O is equals to 1, and then 0, then 1, and then 0, 0. Still a total number of 5 bits, so that will be 0.03125 for the probability. And letter P is equals to 1, and then 0, and then 0, a total number of 3, so that is probability 0.125. For the letter T, we have 0, 1, a total number of 2 bits, so 0.25, and then the Y is equal to 0, 0, so still a number of 2 bits, so a probability is 0.25. So for the probability method, I have here the solution. So 2 times 0.25 times 2 plus 2 times 0.125 times 3 plus 2 times 0.0625 times 4 plus 4 times 0.03125 times 5 is equal to 2.875 bits. And for the second, using the Hartley equation and the Hartley function, the solution is negative times 2 times 0.25 log of 0.25 to the base 2 plus 2 times 0.125 log of 0.125 to the base 2 plus 2 times 0.625 log of 0.0625 to the base 2 and 4 times 0.3125 log of 0.3125 to the base 2, and then a total of 2.87 bits for the entropy of this binary machine number 2. So next, this is the summary of both machine that we have just shown to you. So the machine number 1 is has entropy of 2.4375, and machine number 2 has an entropy of 2.875. So for the maximum entropy, that will be 3.321928. And how do we able to get that is equals to log of the total number of elements to the base 2. And then for the machine number 1, it has the lowest entropy, most predictable, and high probability, and least random, and where the less information needed to be transmitted to get the desired outcome. For the machine number 2, it has the highest entropy, less predictable, lower probability, and most random. More information needed to be transmitted to get the desired outcome. So where the machine number 1 is better than machine number 2. Alright, that's it for today, and see you again for my next video. Goodbye.